Every country has something it does better than anyone else. That is normal. What makes India especially remarkable is that India is not transforming just one part of the country at a time. India has 1.4 billion people. It also has some of the hardest terrain on the planet. That combination forces solutions that no other country ever has to invent, because no other country faces the same problem in the same shape. Here is what comes out of that kind of grit and ambition. Let's get to the list. Number 15. Laying a highway sounds simple until you understand the timing problem. The hot asphalt used to build the road has to reach the paving machine at exactly the right temperature. If it gets too cold, it will not stick and compact properly. Once it is laid, road rollers have only a limited amount of time to press it down before it cools and hardens. That means the trucks carrying asphalt, the paving machine, and the rollers all have to work together without delays. If even one part of that chain stops for too long, the entire paving operation can come to a halt, and that section may have to be done again. In January 2026, on the Bengaluru to Kadapa to Vijayawada Economic Corridor in Andhra Pradesh, the National Highways Authority of India decided to find out how far that could be pushed. On January 6th, near Puttaparthi, crews laid 28.89 lane kilometers of bituminous concrete in 24 hours, placing 10,655 metric tons of material in the same period. Both were world records. 5 days later, they went considerably further. On the 11th of January, working across two packages of the corridor, they laid 57,500 metric tons of bituminous concrete continuously and paved 156 lane kilometers without stopping, the equivalent of a 3-lane road running 52 kilometers. The previous world record for continuous paving stood at 84.4 lane kilometers. India nearly doubled it. 4 Guinness World Records came out of a single construction push. Quality assurance was carried out with support from IIT Bombay and equipment manufacturers, which matters, because a road that gets built fast and fails in 3 years is not an achievement. The full corridor is planned as a 343-kilometer, 6-lane access-controlled highway. It is still under construction, but 1 week of it rewrote 4 global benchmarks. Number 14. Cutting a tunnel through a mountain is difficult anywhere. In the high Himalayas, the mountain is the easy part. At altitude, the air is thinner, which affects both workers and machinery. Extreme cold changes how equipment behaves. Snow can close access roads for weeks, meaning the season available for construction shrinks dramatically. Before any tunneling begins, simply getting heavy equipment to the site is its own logistical operation. In Arunachal Pradesh, the road toward Tawang crosses Sela Pass. In bad weather, that route can become unreliable or impassable, which is a serious problem for the communities that depend on it, and a strategic problem for a state that borders China. India had 2 options: keep fighting the weather on top of the mountain, or take the weather out of the equation entirely. It chose to go underneath. The Sela Tunnel opened in March 2024. One section runs roughly 980 meters. A second tunnel system extends about 1.5 kilometers and includes a parallel escape tube for emergencies. The whole project sits above 13,000 feet. Indian authorities described it during construction as the world's longest bi-lane road tunnel at that altitude. But the record is not really the point. The point is what changes underneath it. Outside, winter can shut the pass down completely. Inside the tunnel, traffic keeps moving. For people living in the region, that is the difference between dependable access and being cut off. For the Army, it is the difference between a supply route that works in January and one that does not. India looked at a mountain pass that nature could close and built a route out of it. Number 13. This world record involves databases and approval systems. The question India tried to answer was this: can a government provide health protection at a scale measured not in millions of people, but in hundreds of millions, while the underlying hospital network is still being built? Most countries would say wait. Build the hospitals first, then the coverage. India built the coverage layer while the system beneath it was still developing. Ayushman Bharat, PM Jan Arogya Yojana, covers a core beneficiary base of 12 crore, that is 120 million families. It was later expanded to include 6 crore citizens aged 70 and above, regardless of their income. Eligible families receive cashless treatment for covered secondary and tertiary care, with annual coverage of up to 5 lakh rupees per family. In 2026, the last remaining state joined the framework, taking implementation across all 36 states and union territories. By February 2026, more than 11.69 crore hospital admissions had been authorized under the scheme across more than 36,000 impaneled hospitals. The World Health Organization describes it as the world's largest government-funded health assurance program. One feature deserves particular attention because it solves a problem specific to India. The country has enormous internal migration, people from one state working in another. A health scheme tied to your home state is useless if you fall ill 1,000 kilometers away. So PM Jan Arogya Yojana was built to be portable. By June 2026, more than 2.9 million interstate admissions had been authorized. The coverage travels with the person. The scale makes it even more remarkable. India did not wait until every problem was solved before building the national layer. It built the layer while other problems were still being worked on. Number 12. For about 80 years, the Pentagon was the world's benchmark for an impossibly large office building. It was the thing you compared other buildings to when you wanted to say something was huge. Then the record moved. Not to another American city, not to China, to Surat in Gujarat. The Surat Diamond Bourse contains roughly 659,611 square meters of floor area, around 7.1 million square feet. 9 interconnected buildings run along a central spine, with more than 100 elevators and thousands of offices, all built around Surat's diamond cutting and polishing industry, which handles a very large share of the world's diamonds. Guinness World Records recognizes it as the largest office building on Earth. By floor area, it surpassed the Pentagon. That comparison lands hard, especially for American viewers, because the Pentagon already feels absurdly oversized. India built something larger. For decades, the world had one famous benchmark for enormous office buildings. A commercial project in Gujarat moved it. Number 11. Imagine having to deliver one essential product to a customer base more than twice the size of the entire United States. Regularly, month after month, across mountains, deserts, cities, villages, and migration routes. The product is food. At that scale, it stops being a welfare scheme and becomes one of the largest logistics operations on the planet. Grain has to be procured from farmers, stored in warehouses, moved by rail and road across a subcontinent, tracked through the supply chain, and matched to eligible households through a network of roughly 500,000 fair-price shops. The United Nations World Food Program states that India's food-based social protection system includes the world's largest food distribution program, reaching more than 800 million people with subsidized rations. 800 million. That is more than twice the population of the United States, receiving food support through a single national system. And it is not one giant distribution center with good software. It is a network operating across one of the most geographically and socially varied countries on Earth. The same system that has to work in a Himalayan village and in central Mumbai. Number 10. There is a point on a mountain where building a normal road stops being a normal engineering problem. The air thins enough to weaken both workers and engines. Cold damages machinery. The construction season shrinks to a few months. Asphalt has to survive brutal freeze-thaw cycles that tear ordinary road surfaces apart. And every piece of equipment has to be hauled up there before any work can start. Most road projects never come close to that limit. In Ladakh, Indian engineers went looking for it. Umling La sits at 5,798 meters above sea level, 19,024 feet. To understand how extreme that is, use a reference point most people already know. Everest's South Base Camp is at roughly 17,600 feet. Umling La is about 1,400 feet higher. This road runs above the altitude where elite mountaineers spend days acclimatizing before they even begin their summit push. Guinness World Records recognizes it as the highest altitude road in the world. Certified in 2021, it is the oldest entry on this list, and it is a proper paved road. Not a trekking route, not a temporary track cut for one expedition. Vehicles drive on it. At that altitude, the available oxygen is roughly half what it is at sea level. Workers tire much faster, engines lose power, and even after construction finished, maintenance crews still have to clear snow and manage extreme temperature swings to keep it usable. India did not just build a road high in the mountains. It built the highest one there is. Number 9. Identity seems like a simple thing until a country has to make it work nationally. A person needs to open a bank account, receive a government benefit, verify a record, and prove that one name belongs to one real individual and not to three fraudulent ones. Now scale that across more than 1.4 billion people, from dense megacities to villages hundreds of kilometers from the nearest town. At that point, it is not an ID card problem. It is national infrastructure. India built a shared identity layer around a unique 12-digit number with enrollment that can include fingerprints, iris scans, and basic demographic details. By March 2026, it had approximately 1.34 billion live holders. That is not a database statistic. That is very nearly an entire civilization inside one identity framework. Aadhaar became the foundation for a much wider set of digital public infrastructure, connecting into banking, government benefit transfers, and financial inclusion programs. It is a large part of why a villager can receive a government payment directly into a bank account, instead of watching it disappear through layers of intermediaries. A system this large also carries serious responsibilities. A biometric database covering more than a billion people raises real and legitimate questions about privacy, data security, exclusion, and what happens to someone when authentication fails and they cannot prove who they are. Those debates are ongoing in India, and they matter precisely because the system is so large. But the record is not in dispute. No other country has built a biometric identity system operating at anything close to this scale. Number 8. Most large national operations happen mostly in cities, where the people and the infrastructure already are. An election cannot work that way. It has to reach everyone everywhere on the same schedule. That means dense urban neighborhoods and remote islands, forests and deserts, mountain communities thousands of feet up. Equipment has to arrive securely, officials have to be deployed, every polling station has to open on time, and everything has to come back safely afterwards. In India's 2024 general election, the registered electorate was approximately 979.8 million people. Around 646.4 million votes were cast. More than 1.05 million polling stations were established, and the whole operation ran across 7 phases. No election in history has operated at that scale. The registered electorate alone was almost 3 times the entire population of the United States. But the number is not the most impressive part. What is genuinely remarkable is how far the system travels for very small numbers of voters. Tashigang in Himachal Pradesh has hosted a polling station above 15,000 feet. Election teams routinely travel by boat, helicopter, road, and on foot to reach voters in places where no road exists. The principle is that if a voter is registered, the election comes to them, regardless of how difficult that is. So in some districts, an election is effectively an expedition, and then the entire machine, a temporary national voting network built for nearly a billion people, is dismantled. A few years later, it has to be rebuilt from scratch and work perfectly again. Most countries will never have to manage democracy on a scale this massive. India does it every single day. Number 7. A rocket engine is one of the least forgiving machines humans build. Extreme heat, extreme pressure, and fuel moving through complex internal passages leave almost no margin for error. Traditionally, an engine is assembled from many precision-manufactured parts. Every joint between those parts is another interface that has to be machined correctly, sealed correctly, and trusted completely under enormous stress. More parts means more work, more weight, and more places where something can fail. So an Indian startup asked an uncomfortable question. What if far more of the engines simply came out of manufacturing as one integrated piece? On May 30th, 2024, a vehicle lifted off from Sriharikota using an engine built on exactly that idea. The company was Agnikul Cosmos, a startup incubated at IIT Madras. Indian science agencies described it as the world's first single-piece 3D printed semi-cryogenic rocket engine demonstrated in flight. The complex internal passages that would normally require assembly were instead built directly into the structure through additive manufacturing. The launch was a technology demonstrator rather than a commercial orbital mission, and that distinction is worth being clear about. But what flew had not been flown in that form before. The flight also lifted off from Dhanush, India's first privately developed launch pad. That combination is why this belongs on the list. India's space story is no longer only a story about a government agency. Private Indian companies are now building their own launch infrastructure and taking their own engineering bets. That is the point at which a space program starts becoming a space industry. Number 6. Humans have been watching the sun for as long as humans have looked up. Modern telescopes study it constantly. Multiple spacecraft photograph it in extraordinary detail. By 2025, it would be reasonable to assume the easy discoveries were long gone. Solar flares release enormous amounts of magnetic energy. They can disrupt satellites, radio communications, navigation systems, and even electrical grids on Earth. Scientists want to understand precisely how that energy moves through the different layers of the sun's atmosphere, which requires observing specific features in specific wavelengths at specific altitudes in that atmosphere. In February 2025, ISRO reported that the Solar Ultraviolet Imaging Telescope aboard Aditya L1 had captured the first-ever image of a solar flare kernel in the lower solar atmosphere in near ultraviolet wavelengths. Aditya L1 is India's first dedicated space-based solar observatory. It operates near the first Sun-Earth Lagrange point, roughly 1.5 million kilometers from Earth in the direction of the Sun, which allows it to watch the Sun almost continuously without Earth getting in the way. The observation gave researchers a new way to connect activity in the lower solar atmosphere with higher energy flare behavior above it. That is the moment a space program changes character. It stops simply repeating missions that other countries have already flown and starts contributing observations that did not exist before. India did not just send a spacecraft toward the Sun. It sent one and brought back something nobody had seen in that form. Number 5. Almost every conversation about clean hydrogen arrives quickly at the same method. Electrolysis, where electricity splits water into hydrogen and oxygen. But electricity is not the only useful output of an energy system. Heat is, and large amounts of high-temperature heat are exactly what certain nuclear reactors produce. An Indian research team connected those two facts. The process uses a sequence of chemical reactions called the copper-chlorine thermochemical cycle. Chemicals circulate through the system, and water is ultimately split to produce hydrogen. The unusual part is not the chemistry, it is where the heat driving that chemistry comes from. On June 29, 2026, India inaugurated a facility at the Indira Gandhi Center for Atomic Research in Kalpakkam. The process heat source was a fast breeder test reactor. India's Department of Atomic Energy described it as the world's first facility using that specific combination. The honest caveat matters here. This is a technology demonstrator, not a commercial hydrogen plant. Its purpose is to test whether the engineering works and whether it can eventually scale. It may or may not, but that is exactly why it counts. Somebody has to build the first machine that takes an idea out of a research paper and into the physical world. The questions it is testing are significant ones. Could nuclear plants eventually produce more than electricity? Could reactor heat help make low-carbon hydrogen for heavy industries that are very difficult to run on electricity alone? Nobody knows yet. But for this particular approach, India built the first one. Number 4. A real city takes decades to become a city. Roads get added, power spreads, hospitals are built, water systems expand, neighborhoods fill in gradually. Now invert every part of that. Build a city on a floodplain. Make most of it temporary. Design it for enormous, unpredictable surges in population. Operate it for about 6 weeks, then take it apart. That was the challenge at Prayagraj in 2025 for the Maha Kumbh. Tent districts went up. So did electrical distribution, hospitals, police posts, and pontoon bridges across the river. Railways added special services. Digital systems monitored crowd movement in real time. Then the people arrived. Across 45 days, reported attendance climbed above 66.3 crore, more than 663 million visits. That figure needs precise wording because it is frequently misreported. It does not mean 663 million unique individuals. Many people attended more than once, and crowd estimates at this scale are exactly that. Estimates. But even with those corrections applied, the number remains extraordinary. The entire population of the United States is roughly half of it, which means the achievement is not a lot of people showed up. The achievement is the temporary operating system built to handle them. There is also a failure that any honest account has to include. On January 29th, a crowd crush at the event killed dozens of people and injured many more. That is a serious and real cost, and it sits alongside everything else here. But the underlying logistical problem remains almost without comparison anywhere in the world. For 6 weeks, a floodplain had to function like a megacity under extreme and shifting population loads. Then the city had to disappear again. Most event planners think in terms of stadium capacity. India had to think in terms of populations. Number 3. Here is the simplest way to picture the Chenab rail bridge. Take the Eiffel Tower. Stand it at the bottom of a Himalayan gorge. Now imagine a train passing above its tip. That is not an exaggeration. The railway deck sits 359 meters above the river below. The Eiffel Tower reaches about 330 meters to its tip. The track runs roughly 35 meters higher than that, but height is only the part a photograph can convey. The structure also had to be engineered to survive strong winds, difficult Himalayan geology, and significant seismic risk. It spans 1,315 meters, is designed to withstand winds of around 260 kilometers per hour, and has a planned service life of 120 years. It is the world's highest railway arch bridge, and India did not build it as a standalone showpiece. It is one component of the 272-kilometer Udhampur to Srinagar to Baramulla rail link, a route that includes 36 tunnels totaling roughly 119 kilometers and 943 bridges. Those numbers describe the actual scale of the problem. This was not track being laid across an open plain. It was a railway threaded through the Himalayas, tunnel by tunnel, bridge by bridge, across decades. In June 2025, the line reached its milestone moment when train services ran across the completed route. What it delivers is all-weather rail connectivity to the Kashmir Valley, a region where road links can be cut by snow and landslides for extended periods. The bridge is the image everyone remembers. The connectivity is what actually changes life on the ground. Number 2. The object at number 2 costs almost nothing to produce. It is a square of printed paper. It sits beside tea kettles, on taxi dashboards, at vegetable carts, and in tiny neighborhood shops. The International Monetary Fund describes UPI as the world's largest retail fast payment system by transaction volume. India built a shared set of rails for everyday digital payments. Different banks and different apps all connecting to the same underlying system, so that any user of any app can pay any merchant, including a merchant whose entire payment infrastructure is a printed QR code. Scan, approve, and money moves between bank accounts in real time. That interoperability is the crucial design decision. It means a street vendor does not need a card machine, a merchant account, or a monthly fee to accept digital payment. The cost of participating drops to almost zero. Then the users came. By June 2026, government data showed roughly 554.9 million users onboarded. During the 2025-26 financial year, the system processed about 241.6 billion transactions, worth more than 314 lakh crore rupees. Here is the comparison that makes people stop. Between July and September 2025, UPI processed about 59 billion transactions. Over the same 3 months, MasterCard processed roughly 54 billion transactions worldwide. These are not identical businesses, and the comparison is not perfectly like for like. MasterCard operates across borders, currencies, and a completely different commercial model. But transaction volume is transaction volume. One country's domestic payment system moved more transactions in that quarter than a global card network moved across the entire world. And the most important detail is where those payments happen. Not just in airports and shopping malls, but at tea stalls, in auto rickshaws, at food carts, and in small shops selling items worth a few rupees. That is the point at which digital infrastructure stops being a convenience for the wealthy and becomes genuine national infrastructure. UPI-linked arrangements are now expanding to other countries. For decades, the question in global technology was when India would adopt systems built elsewhere. This time, the rest of the world started studying the Indian model. Number one. Number one begins with a failure. 4 years before the success, India attempted a lunar landing and lost contact during the final descent. The lander crashed. The mission failed in the most public way possible. That could have ended the program. Instead, engineers went back through the data, identified what went wrong, and rebuilt the next mission around one ruthlessly simple objective: land safely. The target was the moon's southern polar region, an area that is genuinely hard to land in. The lighting is difficult, shadows are long, and terrain hazards can be hidden from cameras. Most previous successful lunar landings had happened much closer to the equator, where conditions are far more forgiving. Days before India's attempt, another major space power tried to reach the same broad region. Its spacecraft crashed. Then on August 23, 2023, the Vikram lander began its descent. Its job was to kill horizontal velocity, control its rate of descent, read the surface beneath it, identify hazards, and make the final landing decisions autonomously, while mission control, 384,000 kilometers away, could only watch. The altitude dropped, the velocity fell, and Vikram landed intact. India became the fourth country ever to soft land on the moon, after the Soviet Union, the United States, and China. But it became the first to do it in the southern polar region, at around 69.37 degrees south. Not the geographic pole itself, but farther south than any successful landing before it. The Pragyan rover then rolled down onto the surface and began studying temperature, plasma, seismic activity, and the chemical composition of lunar soil. And unlike most space milestones, this one did not stop generating results when the news cycle moved on. In 2025, Indian researchers reported evidence that material measured near the landing site may include primitive lunar mantle material excavated by the ancient South Pole Aitken impact. In July 2026, scientists reported that the geochemistry measured by Pragyan closely resembles ALHA 81005, the first meteorite ever identified as having come from the moon. The location matters enormously for what comes next. Permanently shadowed craters near the lunar poles may hold water ice. Water means drinking water for astronauts, oxygen, and potentially rocket propellant manufactured on the moon rather than carried there. That is why every major space program is now focused on the lunar south. India got there first, and no later mission can change the order of arrival. The world had already been to the moon. India found somewhere on it that nobody had reached. India is increasingly operating at a scale that forces unusual solutions. Sometimes the pressure comes from population. You cannot run a normal identity system or a normal election for 1.4 billion people, so you have to invent something new. Sometimes it comes from geography, where an ordinary road or an ordinary railway simply will not survive the terrain. Sometimes it comes from working with limited resources, which pushes engineers toward cheaper and more inventive answers. And sometimes it comes from a straightforward decision to stop following someone else's playbook. None of this means India has solved its problems. Those debates are important, and they deserve to be discussed seriously. But that is exactly what makes the list interesting. India is not waiting to become a fully organized, problem-free country before attempting difficult things. It is building while fixing, scaling while learning, testing while growing. For decades, the global question about India was whether it could catch up. That question is starting to sound out of date. A different one is replacing it. What happens when a country of 1.4 billion people starts designing systems specifically for its own scale? And some of those systems turn out to be larger, faster, or simply different from anything ever built. Tell us in the comments which project amazed you the most. Thanks again for watching. Subscribe for more stories like this and share this video with someone who would love to see it. I'll see you in the next one.